Hi, I'm Steve Gorski, and I'm working with my partner, Hunter Maxon. We decided to work on a DC injection braking current, and we started out with our power circuit at 240 volt AC, three-phase. From there, we wanted to discuss the control circuit, and we used a step-down transformer that took the 240 volt down to 124 or 120 volt. And part of our project was to do a couple calculations in this circuit. So the first one we wanted to show was our RMS versus peak voltage. The 120 volt RMS, we divided that by 0.707 factor, which gave us 169.7 peak voltage. The second calculation we did, we wanted to find out what the value of R1 in our circuit is. So we used the 100.7 peak volt, and we subtracted out 1.4 volts for our diode, and we came up with 168.33 volts. Then we used that and multiplied it by 0.637, which is the average factor, and we came up with 107.2 volt average. From there, we just used the basic Ohm's law. We had 107.2 volts. We divided it by our 2 amps in the circuit, and we came up with 54 ohms. And to isolate the R1, we had the 54 ohms minus the 10 ohms in the rest of the circuit, which gave us 44 ohms for our R1 value. We used a full bridge rectifier in the circuit, which narrowed it down to the DC that we needed to incorporate the injection braking. And Hunter will show how that is hooked up and how it functions separately on his circuit that he used Constructor with. And that is all.
Here on the Constructor software, I have our DC injection braking system set up. From here, we have the 240 volts coming in, and then it heads to the step-down transformer that goes it down to 120 volts AC. And then over here, we have our three-phase motor. And here we have our H-bridge AC to DC rectifier that will make it so that the DC will be able to be induced into the motor to stop it. So we're going to press the forward to start the engine, get it going forward. And our timed relay after 5 seconds closes that to make current go through. And if we hit the stop button, it stops the motor. So we're going to hit the forward again. As you can see, the motor is going. Then you have the timed relay that's got set off. And then when the B1 coil is energized, it will induce a DC current into the motor and then stop it. And that is how our DC injection braking system will work.